അല്ല നീ രണ്ട് കൈയിട്ട് പിടിച്ചോ. ഓക്കെ. Good evening, good evening. Is it audible? Good evening, good evening. Is it audible right now? Is it audible? Dear students, is it audible? Please comment. Okay, we can start now. Hello, my dear students. Welcome to GoScore Learning. We are the GCC's fastest growing EdTech company. Our main aim is to provide education for all. So, in the previous class, we discussed about the applications of derivative. In part 1, we discussed these two topics, rate of change of quantities and increasing and decreasing function. Then today we will discuss about maxima and minima. Before that, we will discuss two questions from increasing and decreasing function. So first of all, we can start from increasing and decreasing function. So in previous class we discussed that topic, but it is very important. So I am discussing two more questions from that side. So in previous, what we discussed is in increasing function, f dash of x greater than 0, right? F dash of x greater than 0, it is called as, it is increasing function or it is strictly increasing function. Increasing function and strictly increasing function. If f dash of x less than 0, it is decreasing function and it is strictly decreasing function. It is strictly decreasing function. So if f dash of x, that means f dash of x greater than 0, it is increasing function, or we can say it is strictly increasing function. Then f dash of x less than 0, it is simply, we can say it is decreasing function, or we can say it is strictly decreasing function. So first we will discuss, show that the function given by f of x is equal to sin x is increasing in this limit, in this 0 to pi by 2, and decreasing in pi by 2 to pi, and neither increasing nor decreasing in 0 to pi. So for a increasing and decreasing function, first I will write f of x. What is f of x? In this question it is sin x. Is sin x. It is sin x. So what will be the derivative of this one? Derivative of sin x. Derivative of sin x is cos x. So we will write f dash x is equal to cos x. F dash of x is equal to cos x. Then we will take some values for in this limit. So limit is 0 to pi by 2. What is cos 0? What is cos 0? Cos 0 is 1. Cos 0 is 1. Next I am taking cos 5 by 4. That is cos 45. Cos 45, it is 1 by root. 1 by root. Then I am taking, so middle value I am taken it as cos 45, and last I will take cos 5 by 2. 5 by 2. What is cos 5 by 2? Cos 90. Cos 90 is 0. 0. So this f dash of x, this f dash of x greater than 0. F dash of x in this limit, it is always, that means 0 to pi by 2, this f dash of x is always greater than 0. So it is an increasing function in 0 to pi by 2, right? So we can move on to the second one. So this one is the first one. Second, decreasing in pi by 2 to pi. Decreasing in pi by 2 to pi by 2 to pi. Pi by 2 to pi. Again, function is f of x. F dash x is derivative of sin x. It is cos x. Cos x. Again, we will give the values from pi by 2 to pi. So, what is cos pi by 2? What is cos pi by 2? Cos pi by 2 is cos 90. Cos 90 is this 0. Cos 90 is 0. Then I am taking cos 3 pi by 4. Cos 3 pi by 4 is 135. Cos 135. That is equal to, we can write it as cos pi minus pi by 4. Cos pi minus pi by 4. What is cos pi minus pi by 4? It is cos pi minus pi by 4. It is minus cos pi by 4. So it is minus 1 by root 2. The value is minus 1 by root 2. So then we will find cos pi. What is cos pi? Cos pi is minus 1. Cos pi is minus 1. So it is f dash of x. It is clearly, it is less than 0. That means f dash of x less than 0. F dash of x less than 0. F dash of x less than 0. So we can say this one is decreasing in this limit. This one is decreasing in this limit. Next, it is neither increasing nor decreasing in 0 to pi. That means it is 0 to pi. Okay. In first one, that means 0 to pi by 2. 0 to pi by 2, it is increasing function. Then pi by 2 to pi by 2 to pi, it is decreasing function. So increasing, decreasing. So it is simply, we can say it is a neither increasing nor decreasing function. So it is 0 to 0 to pi by 2 union. So pi by 2 to pi, it has increasing and decreasing function. That means 0 to pi by 2, it is an increasing function. Pi by 2 to pi, it is a decreasing function. So it is neither increasing nor decreasing function. So it is a mean function. It is same as like this parabola. Increasing and decreasing function. It has positive slope and negative slope, right? So this one is the solution for this question. Next question. Find the intervals in which function f given by f of x is equal to 4x cube minus 6x square minus 72x plus 30 is increasing and decreasing. We want to find this function is increasing function or decreasing function or mean function. We want to check. Okay. Also, we want to find this one. Also, we want to find this function. Okay. Sorry, intervals. We want to find this intervals. So first I will check f of x. What is f of x is given 4x cube minus 6x square minus 72x plus 30. Okay, what is f dash of x? In increasing function or decreasing function, we will check with f dash of x greater than 0 or less than 0. Okay, so f dash of x is equal to, what is the derivative? 4 into 3x square minus 6 into 2x minus 72. Okay. 4 into 3, 12x square minus 6 into 2, 12x minus 72. Okay. So, yes. So, it is equal to, we can take 12 outside. What is 12? We can take outside. So, what will be the 12x square minus 12x minus 72 is equal to, we can take 12 outside. So, it is equal to 12 into x square minus x minus 72. 72 divided by 12. 72 divided by 12. 72 divided by 12, it is 6. That means 12 into 5, it is 60. Then 12 into 6 is 72. So, it is 6. Okay. Then, next step, we will find the intervals. How can you find the intervals? F dash of x is equal to 0. F dash of x is equal to 0. So, it is equal to 12 into x square minus x minus 6 is equal to 0. So we can write x square minus x minus 6. 0 divided by 12, it is again 0. Again 0. Okay. So it is x square minus x minus 6 is equal to 0. So how can you factorize this one? So this one. So it is here it is minus 6 and sum it is minus 1, product it is minus 6. So sum it is minus 1, product is minus 6. So minus 3 and 2. You can check. Minus 3 into 2 it is minus 6 product. Minus 3 plus 2. Minus 3 plus 2 is minus. So we can factorize x square minus x minus 6. X square minus x minus 6 as x minus 3 into x plus 2 is equal to 0. So we can check. X into x, x square. Yes. Minus 3x plus 2x, it is minus x. Minus 3 into 2, it is minus 6. So the limits are x minus 3 is equal to 0 and x plus 2 is equal to 0. So x is equal to 3 and x is equal to minus 2. So we can write x is equal to 3, x is equal to minus 2. These are the limits. So we can draw on a number line. So we can draw this on a number line. So this one is minus 2. 1 second. This one is minus 2. This one is 3. This one is infinity. This one is minus infinity. Okay. So the limits are, we can write the limits are, first limit is or interval is minus infinity to minus 2. Then second, minus 2 to 3, minus 2 to. I am drawing this x is equal to 3 and minus 2 on this number line. Then I will find the interval. So minus 2, minus infinity, minus 2 is the first interval. Second interval is minus 2, minus 3. Minus 2, minus 3. And third interval. What is the third interval? What is the third interval? You can check it. What is the third interval? It is 3 comma infinity. 3 comma infinity. So these are the three intervals. So we want to check, after finding intervals, we want to check it is increasing or decreasing function. Okay. So I will add a slide. Okay. So again I am writing the limit. It is minus infinity minus 2, then comma minus 2, 3 and 3 comma infinity. 3 comma infinity. 1 second. I want to check that minus infinity minus 2. Yes. Then minus 2 minus 3. Minus 2 3. Then 3 infinity. So these are the three values. Next we want to check this one is increasing, decreasing or int function. Okay. So before that I will draw a table. So first I will mark this interval. First interval. Second, sine of f dash x, not f of x, sine of f dash x. Then nature of functions. Last, nature of functions. Nature of functions. So first I will mark this minus infinity, comma minus 2. Second, minus 2, 3. Third one, 3 comma infinity. 3 comma infinity. So here you can see both are negative. Infinity and minus 2 is negative. So both are negative. Here you can see minus 2. 2 is negative and 3 is positive. Then here both are positive. Both are positive. So here both are negative. So we can write it is greater than f dash of x is greater than 0. If both are same sign, we can write it as it is greater than 0. So both are same sign, plus plus, it is greater than 0. Here minus minus, greater than 0. One sign is changing, minus plus or plus minus, it is less than 0. That means first one, f dash of x is greater than 0. What will be the function? Function is increasing. Function is increasing. Here both are negative, both are same signs, it is greater than 0. So f dash of x is greater than 0. So function is increasing. Here also plus plus, it is f dash x greater than 0. Again function is increasing. Here minus plus or plus minus, it is f dash of x less than 0. So function is decreasing. Function is decreasing. So we can say that this function increasing, decreasing, increasing. So as we discussed in parabola, in parabola, this one is decreasing, then increasing, decreasing, increase. Okay. So at that time we will write it as a nin function, neither increasing nor decreasing function. Here also you can see that this function is first increasing, then decreasing, again increasing. So which type of function is this one? Which type of function is this one? This one is simply nin function, neither increasing nor decreasing. So if you write in this method, you will get full marks. Okay. First you want to find these limits. After that, you will check with this table and find which type of nature of this function. Here the nature of the total function is increasing, decreasing, increasing. So it is neither increasing nor decreasing. So it is a nin function. Okay. Nin function. Okay. So next we can move on to maxima minima. It is another important concept. Only three concepts you want to study in applications of derivative. First one is rate of change of quantities. Second one increasing and decreasing function. And third one maxima minima. In maxima minima, you can see I am drawing a function. Here the slope is positive. This one is slope is positive, slope is negative. You can see slope is positive, slope is negative. Then here we can this one is slope is negative, then slope is positive in this graph. Okay, before moving to maxima minima, I will give a concept of absolute maxima minima, then absolute maximum value, absolute minimum value, then local maxima, local minima. So we will discuss all maxima minima in this class. So let me take a graph. You can draw any type of graph. So I am drawing a graph. So in this graph, this interval, I am marking an interval. This interval is A, this interval is B, this interval is B. So in this function, this is y is equal to f of x. This function is y is equal to f of x. In maxima minima concept, we will discuss, we can use graphs, then range of the function, then third one derivative test. That means first order derivative, or we sometimes we will use second order derivative test. Okay. So this, in this graph, you can see it is, there is an interval. There is an interval. Interval starts from A and intervals is ending at B. So at starting you can see it is the maximum value. In this graph, it is the highest value. In this graph, it is the highest value. So we can say that this value is absolute maxima. Absolute maxima. So that value in a graph, the topmost value, it is called as absolute maxima. Then here you will get a value. Here in this axis you will get a value. It is called as absolute maximum value. This one is absolute maximum value. You got the difference. Here in the x-axis, that value is called as absolute maxima. Then in this, it is the highest value, it is called as absolute maximum value. Then so in this graph, in any graph, there is only one absolute maxima and absolute maximum value. Okay, in any graph, there is only one value, only one absolute maxima and absolute maximum value. So we can discuss next one here. So in this graph, you can see this one is the minimum value. This one is the minimum. Oh, 1 second. Okay, this one is B. So this one is the minimum value. So this one is the minimum value. So that minimum value is called as absolute minima. So the lowest value in this graph, it is absolute minima, and here you can see this value. Here you can see this value is called as absolute minimum value. This one is absolute minima. This one is absolute minimum value. Next, I will explain about local maxima and local minima. Okay. Next, I will explain about local maxima and local minima. So, what is local? Sometimes we will say that we are locals. That means we are in that place, in a particular place. We are a local of that area. Sometimes we will say. Okay. So, like that, we will take an interval. We will take a interval. We will take a interval. In that interval, we will take maximum or minimum value. It is called as, or maxima or minima value. It is called as local maxima or local minima. So we will take in a particular interval, that value is called as local maxima or local minima. So I am taking this interval. So this interval is, I am taking x is equal to C1. So this one x is equal to C1. So in this particular interval, this value is maximum. This value is maximum value. So in the x-axis, it is called as local maxima. Here it is maximum value. This one is maximum value. Here it is maximum value. Next, same type, I am taking in another interval. Next, I am taking in another interval. So you can take any interval. You can take any interval in the graph. So in this interval, what will be the value? Anyone can answer? So here, this one is minimum value. This interval, this one is minimum value. This interval, this one is minimum value. So it is, I am taking x is equal to C2. X is equal to C2. So this one is called as local minima. So that value is called as local minimum value. Here it is, that value is called as, in this axis, it is called as local minimum value. So in this axis, we will take it as maximum or minimum value. In this x-axis, we will take it as minima and maxima. Maxima and minima. You got this concept? It is really important. Only you can take this axis, we can take it as a maximum and minimum value. Here we will take it as a maxima or minima value. So this, in a particular interval, it is called as local minima and local maxima, and absolute means it is the highest value in that graph. It is called as absolute maxima, and absolute minima is the lowest value in that graph. So we can discuss then some, okay, based on critical point analysis, we can discuss some first order derivative test and the second order derivative test. Then what is critical point? What is critical point? What is critical point? So we can take a function f of x. Y is equal to f of x. So first we will take derivative of that function. What is the derivative of f of x? Derivative of f of x is f dash x. Derivative of f of x is f dash x. So in the f dash x is equal to 0. This value is equal to 0 is called as critical point. So f dash of x is equal to 0. We will find that x value, that value is called as critical point. Then you got this concept. So f of x in the question, f of x is given. Then we will find f dash x. Then we will equate that f dash of x is equal to 0. Then we will find x value. That value is called as critical point. Okay. So first we will discuss first derivative test. First derivative test, and second one, second derivative test. First derivative test and second derivative test. So first derivative test, we will first find f dash x. Then in f dash of x, I am taking x is equal to c1. So from the left side, it is from positive to negative. That means decreases. It is called as local maxima. Local maxima. Then second one, what is then opposite of this one is local minima. So I am taking again f dash of x. Here it is x is equal to c2, then minus plus from here to here, from left side this minus 2 or increases. Sorry, minus 2 plus, it is called as local minima. Local minima, minus 2 plus. Then sometimes there will be, I will take another example. Third one, this one is second one, f dash of x. F dash of x, third one, it is, there is no sign change. No sign change. There is no sign change from moves from left to right. It is called as point of inflection. Point of inflection. Point of inflection. So there is no sign change from moving from left to right. It is called as point of inflection. Okay. Then what is second order derivative test? In second order derivative test, we will find f double dash of x. After finding f dash of x, we will find f double dash of x is less than 0. We will find local maximum. Local maximum. Then if f double dash of x greater than 0, it is local minima. This f double dash of x greater than 0, it is local minima. Local minima. So this is the basic concept. So we will discuss all the questions. So first question, find the maximum and minimum values if any function f given by f of x is equal to x square. So what is the graph of x square? We can simply solve this question by using graph. So graph of this one is a parabola. F of x is equal to x square is a parabola. So it is increasing and decreasing function. Neither increasing, neither decreasing function we discussed. So based on the this one we can discuss. So here this one is origin. This one is origin. Origin. So what is the minimum value? So this function can attain the minimum value of 0. X is equal to 0. So x is equal to 0 is the minimum value. So what is the maximum value? There is no maximum value. It is going on. So it is there is no maximum. There is no maximum value. There is no maximum value. So x is equal to 0 is the minimum. We will get 0 as the minimum value at x is equal to 0. At x is equal to 0, it is the minimum value and there is no maximum value. So what about mod x? F of x is equal to mod x. F of x is equal to mod x. What is the graph of mod x? It is V-shaped. It is V-shaped graph. This one is mod x graph. So f of x is equal to mod x. F of x is equal to mod x. In this graph, it is clearly minimum value is again 0. Minimum value is again 0. Maximum value, there is no maximum value. In this also find the maximum and minimum value if any of the function is given by f of x is equal to mod x. Okay, so minimum value is 0 this point. Minimum value is 0. Maximum value, there is no maximum value. Here there is no maximum value. Next, find the local maximum and local minimum values of the function f given by f of x is equal to third question. Find the local maximum and local minimum values of the function f given by f of x is equal to 3x raised to 4 plus 4x cube minus 12x square plus 12. So if in maximum yes, in this, if there is a third condition in second derivative test, if there is a third condition, if f double dash of x is equal to 0, if f double dash of x is equal to 0, the second order derivative test fails. Second order derivative test fails, so we will go with first order derivative test. This one is also important. So if f double dash of x is equal to 0, second order derivative test fails, so we will go with first order derivative test. Okay, not explain that one. Okay, so find the local maximum and local minimum values of the function f given by f of x is equal to 3x raised to 4 plus 4x cube minus 12x square plus 12. So first we will find f dash of x. What is f dash of x? What is f dash of x? 4 into 3, 12 x cube plus 4 into 3, 12 x square. Then minus 12 into 2, 24 x. 24 x. So first we will find the critical points. So f dash of x is equal to 0. That means, so in this 12 is we can simplify it as 12x is common, right? 12x is common, so we can write 12x into here it is 12x into x square plus x minus 2. So 12x into x square, 12x cube, 12x into x, 12x square, minus 12x into minus 2x, it is 24x. So we can factorize this one also. Again we can factorize. So here product is minus 2. Product is minus 2. Sum is 1. Sum is 1. So 1 into 1 we can check. 1 into minus 2, it is minus 2. 1 plus minus 2, it is minus 1. So this one is not value. Minus 1 into 2. Minus 1 into 2, it is minus 2. Minus 1 into 2, minus 2. Minus 1 plus 2, it is 1. Yes, correct. So 12 x into 12x into, we can factorize this one. So it is x minus 1 into x plus 2. So we can check x into x square minus x plus 2x s plus x minus 1 into 2, it is minus 2. Okay. So this is the function f dash x is equal to 12x into x minus 1 into x plus 2. Then we want to find the critical point. So how can you find the critical point? So critical point is f dash of x is equal to 0. That means 12x into x minus 1, then x plus 2 is equal to 0. So x is equal to 0, then x minus 1 is equal to 0, x plus 2 is equal to 0. So x is equal to 1, x is equal to minus 2. So x is equal to 0, 1, minus 2. So these are the values. X is equal to 0, 1, minus 2. Next we will find f double dash. So next we will find, so 12x square f dash x is equal to 12x square, sorry, 12x cube, 12 12x cube, then second one plus 12x square plus 12x square minus 24x. So this one is f dash of x. This one is the f dash of x. So first we will find f double dash x. So it is equal to 12 into 3, 36 x squared. Take derivative. That means 12 into 3x square. So 12 into 3 is 36. 36 x square. Then again 12 into 2, 24 x. 24x minus 24. Minus 24. Okay. So this one is f double dash x. F double dash x is 36x square plus 24x minus 24. So we can check again, 12 into 3, 36x square, then 24x, right, minus 24. So we will substitute f dash of x is equal to 0, we will get x is equal to 0, 1, minus 2. X is equal to 0, 1, minus 2. So f double dash of 0, f double dash of 0, we will find f double dash of 0, f double dash of 1, f double dash of minus 2. What is f double dash of 0? 0. We will put 0 in this one. So 0, 0, minus 24. Yes, minus 24. Then, so we can, this one, 12 we can take outside. 12 into, we can reduce this one. 12 into 3x square plus 2x minus 2. Okay. Then 1. What will be if we substitute for 1? 1. So it is 12 into 3 plus 2 minus 2. 12 into 3, 36. Okay. This one is 36. This one is 36. Then last one, minus 2. 12 into 3 into minus 2 whole square plus 2 into minus 2, it is minus 4, minus 2. So 12 into 3 into 2, 2 square, 4 into 2 square, it is, sorry, minus 2 square, it is 4, 4 into 3, it is 12, 12 minus 6. So 12 into 6. What is 12 into 6? 12 into 5, it is 60, then plus 10, 12, it is 72. Yes. 12 into 6, it is 72. So we can check these values based on this second derivative test. If f double dash of x less than 0, it is local maxima. We can find the local maxima. Okay. Local maxima and a maximum value. So yes, this one is less than 0. So we can find this one local maxima. Then this one is greater than 0, local minima. Here this one is greater than 0, local minima. So we want to find, what is the question? This question, okay. Local maximum and local minimum values. Okay. We want to find local maximum and local minimum values. Okay. So first we will find this one is local maxima. This 0 is local maxima because it is less than second derivative of that value is less than 0. So that one is local maxima. So this 0 we will substitute in f of x. What is f of x? What is f of x? F of x is 3x raised to 4. F of x is 3x raised to 4 plus 3x raised to 4, 4x cube minus 12x square. 4x cube minus 12x square plus 12. Yes, plus 12. So first, for finding the maximum value, we will substitute this 0 in the f of x. So f of 0, what is f of 0? 3 into 0 plus 4 into 0. So this term will be 0, second term will be 0, minus third term will be 0, then last term is plus 12. So is 12. So that value is maximum value. F of 0 is the maximum value. Then second we will find f of 1. F of 1 is local minima, 1 is local minima, 1. So 3 into 1 plus 4 into 1 minus 12 plus 12. Minus 12 plus 12. 0, 4 plus 3. 7. So 7 is local minimum value. Okay, this 7 is local minimum value. Then last we will find this third value, minus 2. F of minus 2. What is f of minus 2? 3 into minus 2 raised to 4 plus 4 into minus 2 raised to 3 minus 12 into minus 2 raised to square plus 12. So 3 into minus 2 raised to 4, it is 16 plus 4 into minus 8 minus 12 into 4 plus 12. So 16 into 3, 16 into 18, 48, 48 plus 8 into 4, 4 into minus 8, it is minus 32, minus 32. Then 12 into 4, 12 into, yes, again it is minus 48 plus 12. So this and this will be cancelled. 48 minus 48, 0, minus 32 plus 12. So it is minus 20. So this one is also which value? Minimum value, local minimum value. F of minus 2 is the minimum value. Minimum value. Okay, next we can move on to next question. Find all the points of local maxima and local minima values. F of x is given by 2x cube minus 6x square plus 6x plus 5. Okay. So first we will find f dash of x. First we will find f dash of x. So what is f dash of x? What is f dash of x? 6x square minus then 12x plus 6. Okay. 6x square minus 12x plus 6. Then here we will find, we can take 6 outside. X square minus 2x plus 1. 2x plus 1. So it is equal to 6 into x minus 1 whole square. This one is x square minus 2x plus 1 is x minus 1 whole square. X minus 1 whole square, that is f dash of x. Then, okay, then what is f double dash of x? What is f double dash of x? 12 x 12x. So first value is first value. What is first value? X. We will find the critical point. What is critical point? f dash of x is equal to f dash of x is equal to f dash of x is equal to f dash of x is equal to, what is f dash of x equal to? For finding critical point, it is 0. F dash of x is equal to 0. So 6 into x minus 1 whole square is equal to 0. That is x is equal to, or x minus 1 whole square is equal to 1. X is equal to 1. X is equal to 1. So x is equal to 1. So this one is the, actually this one is point of inflection. That means it is neither increasing nor decreasing function. This one is neither increasing nor decreasing function. So it is a point of inflection function. So this one is point of inflection function. So next question. Next, yes. So this question is very important. Find two positive numbers whose sum is 15 and sum of whose square is minimum. Sum of whose square is minimum. So find two positive numbers whose sum is 15 and the sum of whose squares is minimum. Whose squares is minimum. Here there are two numbers. So I am taking first number bx. I am taking first number bx and second number by. So I am taking two numbers. It is clearly mentioned two positive numbers whose sum is 15. That means x plus y is equal to 15. X plus y is equal to 15. So what will be the value here? X plus y is 15. X plus y is equal to 15. What will be the value of y? Y is equal to 15 minus x. That means second number is 15 minus x. So here second condition is given. The sum of whose squares is minimum. The sum of whose squares is minimum. The sum of whose squares is minimum. So that means x square plus y square. X square plus y square. So it is sum of whose squares is minimum. So I am taking that function as sum of that function is equal to x square plus y square. X square plus y square. X square plus y square. So s of x is equal to, again I am writing x square plus y square. What is y here? What is y here? So it is x square plus y. Y, it is second number. It is 15 minus x. 15 minus x. 15 minus x whole square. So this one is a minus b whole square. A minus b whole square. So x square plus 15 square minus 2 into 15 into x plus x square. So x square plus x square, x square plus x square, 2x square, 2x square plus 15 square, it is 225 minus 2 into 15, 30x, 30x, 2x square plus 225 minus 30. So this one is the function. So this one is the function. So first we will find by using first derivative test. What is first derivative, or what is s dash of x? S dash of x, 2 into 2, 4x plus 225, it is a constant, 0 minus 30, 4x minus 30. While we taking the first derivative of this s of x function, it is 2 into 2x, 2 into 2x, it is 4x. Then this value is a constant value, so derivative of constant value is 0 minus 30, it is minus 30x, it is minus 30. So I am taking second derivative for finding if it is local maxima or local minima. We want to check this function is local maxima or local minima. What is the derivative of this one? 4x minus 30. What is the derivative of 4x minus 30? So this must be a constant. So this value is 0. And what is the derivative of 4x? It is 4. 4. 4 is always greater than 0. 4 is always greater than 0. So you can check. So if f double dash of x greater than 0, it is local minima. So that value is a local minima value. Local minima value. So this value is local minima. So this value is local minima. 4 is always greater than 0. So that value is local minima. So it is clearly the condition, the sum of whose squares is minimum. Yes, it is minimum. So we want to find the two numbers. So what will be x? What is x? X we can find by using equating this value with 0. We want to find the critical point. So what is critical point? Critical point is s dash of x is equal to 0. S dash of x is equal to 0. We want to find the critical point. So 4x minus 30. 4x minus 30 is equal to 0. 4x minus 30 is equal to 0. 4x is equal to 30. X is equal to 30 by 4. So it is 15 by 2. 30 by 4, it is 15 by 2. 15 by 2 is the first value. So first number is 15 by, this value is 15 by 2. Then what is y value? What is y value? Y is equal to 15 minus x. So 15 minus 15 by 2. So it is again 15 by 2. So these are the two numbers, 15 by 2 and 15 by x is equal to 15 by 2. First number. Second number is again 15 by 2. So we can discuss the last question. Find the maximum profit that a company can make if the profit function f given by p of x is equal to 41 minus 72x minus 8 x square. 8 x square. So we want to find the profit. Find the maximum profit that a company can make if profit function is given. Profit function f is p of x is given. P of x is given. So p of x. This type of question will be asked in your board exam. So it is equal to 41 minus 72x minus 18 x square. So first we will find p dash of x. P dash of x. So it is minus 72, then minus 36, x minus 36x. Then we will find the second derivative by using second derivative test. So by using second derivative test, we will find the value. So what will be, this must be a constant. So 0 minus 36. So it is minus 36. So minus 36 is always less than 0. So it is local maxima. Minus 36 is less than 0. Minus 36 is less than 0. So it is local maxima. So we want to find the profit of this company. Profit of this. How can you find the profit of this company? Simple way. We want to find the critical point. So what is critical point? Equate the first derivative to 0. Equate the first derivative to 0. That means p of x is equal to p dash of x is equal to 0. Not p of x. P dash of x is equal to 0. That means minus 72 minus 36 x is equal to 0. Minus 72 minus 36 x is equal to 0. So minus 72 is equal to 36 x. So minus 72 divided by 36 equal to x, or we can write x is equal to minus 72 divided by 36. It is minus 2. Minus 2. So we want to find that value, maximum profit that company can gain or company can get. So P of minus 2 is the value. P of minus 2 is the value. P of minus 2 is the value. So P of minus 2 is equal to 41 minus 72 into minus 2 minus 18 into minus 2 square. Minus 2 square. So 41. 72 into 2. 72 into 2. 4. 144. Yes. Minus plus. Minus into minus. 144 minus 18 into 18 into 2 minus 2 square is 4. So 8 into 4. 32. 3. 1 into 4. 4 plus 72. So what will be the value? What will be the value? What will be the value? 44. 144 minus 144 minus 72 to 7. Again it is 72. So 41 plus 72. So what is 41 plus 72? 41 plus 72. 41 plus 72. 2 plus 1. 3. 7 plus 4. 113. Yes, it is 113 units. So based on this formula, they can gain 113 units. Okay, so these are the main application level questions. Mostly this type of questions will be asked. There are so many questions. The time is not enough for solving that questions. So in next, okay. So we have discussed applications of derivative in two parts. So there are so many questions. So the weightage of, I think, that chapter is around 5 or 6 marks. So next we are going on live on 21st October Saturday with Rahul sir, chapter 5 magnetism and matter, part 1 of physics, grade 12. Stay tuned.